we're going to spend several days working with logarithms, and you're going to be doing a lot of rewriting to simplify them. So today we're just going to start with converting between exponential, which is what you have been, or what you graphed in section 1, and logarithmic forms. So let's just talk about what a logarithm is first. A logarithm is basically an exponent to which a specific base is raised to obtain a given value. Okay, and we're going to be switching back and forth from exponential, where the variable is in the exponent, to logarithmic, where the exponent is set equal to a logarithm. Now you can switch back and forth from one to the other. The logarithmic equation is read as the log base b. So you say the log, and then you have to say base b to identify that that's the base of a is x. So if we have numbers in there, we read it as log base 2 of 8 is 3. Okay, now we're going to move back and forth between forms. So this is your exponential form. So if I would write this in exponential form, it would be 2 to the third equals 8, and it has to be a true statement. So this is the logarithmic form. Let's just do this. This is logarithmic right here. And then exponential would be the base raised to the power, so 2 to the third equals 8. And it has to be a true statement. Now, I always have people think that this is 2 times 3, which is 6, but this actually means take 2 and multiply it by itself 3 times. So 2 times 2 is 4, times 2 is 8. All right, let's just start on this side. We're going to go from exponential, so there's exponents here, to logarithmic. Okay, so what we're going to do is we're going to say log, and this number is your base. So we can also go up here and point to this. That's our base. And this is our base. So the base, when you're writing a logarithmic expression or an equation, is in the basement. It's a subscript, so it goes below. So make sure that you write that below. So log, base goes in the basement, so that's 3. Log base 3 of 9 equals 2. So exponent always is on the side by itself because the logarithm equals the exponent. Now we can check this by going left, right, left. So we go the base raised to the power equals the number, which is what we get right here. All right, so let's do that again. Log base, the base is whatever's being raised to the power. So log base 4 goes in the basement of 64 equals my exponent. And you don't have to write this down. I'm just writing that that's your exponent. All right, next one. Log, looking for the base, whatever's being raised to the exponent. So log base 2 of 0.125 equals my exponent, which is negative 3. So exponent always on the side by itself. You write a logarithm equals an exponent. All right, now we're going to go the opposite way. We're going to start here and go backwards. So the way that you do this, again, you go left, right, left. So you do 2 to the 4th equals 16. So 2 to the 4th equals 16. That's a true statement. And then you have 3, the base, raised to the power, equals the number. So the power is also called the exponent. So 3 to the 4th equals 243. And then last one, 8 to the 0 power equals 1. All right, now there are some special properties of logarithms. And if we have the base and the number that follows the base are identical, that equals 1. Because what we're saying here is what power do you raise b to get 1? I think I just said that wrong. You have a base. What power do you raise it to get the base back? So the base raised to the first power will give you the base back. Just like this, 10 to the first power gives you 10. So if these are identical, the exponent has to be 1 because you're saying what power do you raise 10 to get 10? That has to be 1. The other property is if you have a 0, the logarithm equals 0, this is your exponent, then you know anything to the 0 power equals 1. So anything to the 0 power equals 1. All right. So a logarithm with a base 10 is the most commonly used logarithm. So if no base is written, then you automatically know that base 10, that it's a base 10. So here, we don't have to write base 10 here, but it's assumed. So this is read log base 10 of 100 is 2. Exponent on the side by itself. Okay, you have a few questions to try.